Okay, hello everyone, and welcome to Near Office Hours. Today we have Phala Network with us. Do you guys want to introduce yourself and very briefly say what Phala Network is all about? And yeah.
Yeah, sure. Hi everyone. This is Marvin. I'm the co-founder and CEO of Phala Network, and probably Han can make your own intro very short. What we are doing is to provide off-chain high-performance security computation for Web3. No matter if you are running like blockchains or smart contracts, decentralized applications, AI agent, AI models, you can use Phala's TE service as a coprocessor, for verifiable confidential compute.
Hey y'all, Han, co-founder and the CTO from Phala Network. We have been working on TE for already 5-6 years, so that's quite a journey. Super happy to be here because both Near and the Phala Network is working on very cutting edge stuff.
Yeah. So it's interesting, right? Because TEs have been around for a while, right? Like the first version says GX has been, like it's been at least a decade, right?
Mm-hmm.
But it's only picking up now. For people who don't know yet what the TE is, can you guys like explain it in layman terms? What TE is, why it is useful?
Yeah, I think I can take it. So when I explain to people what is TE, and especially for people who don't have any understanding before, I will take a zero knowledge proof as an example, as a comparison. It's kind of like a zero knowledge proof where you can run some execution off the blockchain. And you can verify what is the program and the correctness of the execution. But it has a lot of interesting property compared with ZK. First is it's super efficient. Like when running ZK, you're going to spend say thousands times of the overhead. So if you spend $1 to run say run some machine learning models, then you have to spend $1,000 for the same amount of the workload, but proved in ZK. So this is one big difference. Another difference is that unlike most of the users. People's understanding, ZK only give you the privacy if you run everything locally. But if you give your execution to somewhere else, for example, you find a ZK-proof cloud, then you don't have the privacy because you still need to give all the inputs, the execution states to someone else. So, but TE is another story. TE can give you all the privacy preserving properties. So essentially, TE is a hardware-based solution. It allows you to put some software or some program into the hardware area. So in this area, it's a secure area. Anyone else, including even the operators of this hardware or the administrator or the operating system, cannot access the data inside this black box. So by putting your program in this black box, nobody else can manipulate how it is executed. It will just exactly executed as how your program is designed, just very similar to smart contracts. And nobody else can see the data running inside. So people cannot steal data from the TE. Combine those two properties as well as the provability, then you have privacy preserving, you have integrity guarantee, and you can also prove that and being verified either on-chain or off-chain. This, still a little bit similar to ZK, but in terms of performance, properties, and how you develop the program running in the TE, those are the big difference. And to me, although ZK has very strong security guarantee, But on the other side, if we don't need that high level of the security guarantee, then we can get huge gain on the performance and privacy.
Yeah. So I think so you compare to ZK proof, right? So ZK proof gives you the guarantee that a particular output is in fact a result of a particular computation on particular input, right? And so TE can also give you that. But then another comparison to the world of cryptography would be fully homomorphic encryption, right? Because with fully homomorphic encryption, I can have someone else run the computation, right? But I will know that they neither saw the inputs nor did they see any intermediate states, nor do they know the output, which I do, right? And like if you combine fully homomorphic encryption and ZK knowledge proofs, zero knowledge proofs, you will get something that has similar guarantees to TEs, right? But both of those today are quite slow, right? And TE works effectively at the speed of computation, right? There's overhead is either almost zero already or getting very close to zero, right?
Yeah, recently we have done some benchmark, and for both for CPU-T and the GPU-T, they are the overhead is almost less than 5%.
Yeah. And I think for Blackwell GPUs, it's going to be even lower, right?
Yeah,
I think so.
Yeah, I can also give some additional comment on the from the market perspective, because Hang is providing from technology or stack perspective, right, point of views. So from what user need, and I would say in Web3 TE can have some extra benefits. Actually, I have a slide for it, but TLDR is we have a matrix called trust list ROI, which means which trust list level you can reach for the computation compared with the potential financial cost and time cost for development. So of course we all know that blockchains like Bitcoin, Ethereum, Near, have extremely high trust list level, and but if you want to reach out into that benchmark, the computation trade-off is kind of very high too. ZKP is kind of match that layer. And the good part of TE is that probably using TE won't get you, let's say, 100 scores of trust list level, but it can easily help you get let's say 80 scores in some way. Using just a centralized Web2 TE can help you get probably 70 scores, but to reach there the cost is extremely low. So it means that using TE for trustless use cases is kind of have a very high trustless ROI. In the meanwhile, another benefit I want to mention is the Web2 friendly. So TE as a tech is super Web2 friendly. So Alex, you mentioned, right, running AI models inside TE is already very possible, and so does many other use cases. For now, if you, as long as you can wrap up the program into a Docker, you can run it into a TE and get some proofs. So the Web2 friendly part means that how much development cost or how's the development cost you need to give away to get on board into Web3. For example, even the most easier smart contract, Solidity smart contract, or some virtual machines for ZK, right? The developers still need to rebuild their original Web2 program and rewrite most of the code base to onboard into Web3. But for TE, is super smoothly migration. That's another benefit. It's super Web2 friendly.
Yeah. So I think it's worth being a little more specific, right? Why you would say 80, not 100, right? So I think there are three main ways in which TE could be less secure than alternatives. The first one is that you do need to trust the hardware manufacturer, right? So like Intel or NVIDIA in this case. Though I think people don't often look at it this way, but you have to trust hardware manufacturer no matter what. even if you don't use the TE, right? What happens when when you buy a laptop and you start using it, right? If the manufacturer of the laptop puts something into the BIOS, right, it's then it doesn't matter if you run fully homomorphic encryption or ZK knowledge cryptography on that machine. That machine is spying on you, right? Then the second is that there are some in the past, in the previous generation of Intel TE technology, people did find side channel attacks and whatnot, right? So like there's always a chance that the new generation, the TDX, will eventually be, there will be some some way of using like a cache or something like that to find, to like peek into what happens inside. And I guess the third one is the most interesting, and I think this is where I personally find DStack, which we need, I guess we will talk about in a second, very helpful, is that TE technology is notoriously complex, right? Like if you try to use it from first principles, right? First of all, documentation is extremely lacking, right? Like if you Google Intel TDX, you will get 10 links of marketing material from Intel, and then only on the second page you will finally find any technical documentation, right? It's even worse with NVIDIA, right? Because the technology is relatively young, right? And I think the beauty here is that with DStack, right, you can abstract away from the complexity of TDX and use it with a very simple abstraction. So I guess, do you guys want to talk a little bit about DStack and which exact abstraction it provides to people?
Yeah, I think this is a really interesting topic because when using TE, usually there are a lot of pitfalls. It doesn't mean if you use a TE, then you're all good. You still need to take care of a lot of things. For example, you run a program, you have the input. Then if the user give you the input, how can you make sure the input you get from the user is not manipulated? Or if it involves privacy, is it encrypted, end-to-end encrypted? So this is one problem, like protecting the input. It also apply to the output. So if the program give out some output, how can we make sure the user can trust the output of this program? And also say, pretty similar to smart contract, Ethereum can be very secure, or like a it's very secure. It's the very fundamental layer, but it doesn't stop people to write a very buggy smart contract. You can have a smart contract with the backdoor. It can still screw up your users. So there are a lot of pitfalls. So especially when using TEE, we're dealing not only with the integrity. This is usually the case of ZKP. You just want to make sure you have a proof, so that as long as you get the proof, then the execution should be correct. But in TEE, usually we also imply that, so we're also dealing with privacy. So privacy is a super hard problem to solve, because even if everything look very good, but at some point, if the privacy is leaked, you even don't realize, okay, someone has already got the privacy. Well, it's even not only the user privacy. Sometimes it's the private keys. So it even can cause someone to lose money. So inherently, we're dealing with a harder problem. So that's I would say one of the biggest source of the complexity. So to deal all those complexity, including say proving the hardware is secure, the input is secure, output is secure, and the program running inside is exactly the program people expect to run, then we need a bunch of things, including say the remote attestation. This is so-called TE proof. You can get a proof so that you can use this proof to establish, easier word is to ensure all the components in this pipeline is good. But only the attestation is not enough. We still need to have multiple components to make sure multiple areas are secure enough. So I do think it's very important to have a very standardized security best practice, and everyone should follow this practice. And of course, following the practice is very hard. So that's why like we try to put all the best practices into the open source project. That's called the DStack. And then on top of that, we have the near private ML SDK. So yeah, by giving, the SDK that minimize the people to minimize the effort for people to deal with the privacy, then people can achieve some high level of the security best practices. So this is the start point.
Yeah. So the way I like to think of this stack is so TE is I think it takes quite a while to fully understand the security model of the TE, right? And it's one thing for me as a developer to understand it when I build it, but the user who uses my product, right, they need to fully understand this security model, because otherwise they do not if there's five steps that ensure the privacy, and any one of them missing means that all the data is public, right? Mm-hmm. The user needs to fully understand all the steps, right? And I think the way I think of this stack is that it removes it simplifies significantly the mental model, right? The stack effectively, and correct me guys if I'm wrong, but the way I think of this stack is that there's like the developer publishes a effectively. So this stack allows you to run Docker containers inside of the CVM, right? So CVM stands for confidential virtual machines, right? So now as a developer, I publish a Docker container, right? And the user will establish a TLS connection to the with the API exposed by the Docker container, right? And then the user can be certain that TLS connection was established, in fact, with the TE, and moreover, not just any code running inside of the TE, but the very Docker container that the user has access to, right? And so then as a user, I say, well, if I manage to establish this TLS connection, then I can be certain the code handling it is this very Docker container, right? So if I can inspect it, and if I don't see any, backdoors, then I can be certain that my data is handled with the code I trust, right? And then I can be certain that it's running inside of the TE, right? So neither the Docker container creator nor the hardware operator can sneak on me, can look at my data, right? And so then it's much easier to design systems running on top of the TE, right? Because now the design, effectively, it all boils down to the API exposed, right? So if it's an inference server, we say, hey, it's a VLLM running, right? You have this OpenAI compatible API, and you know that it's running inside of the TE with a Docker container. So your connection is encrypted by the TLS. The code running inside of the TE is protected by the TE guarantees. So the privacy at this point is implied, right? So it's I like this. It simplifies the mental model for the user, right? And then it makes it much easier to design new systems that take advantage of the TE, because instead of thinking in terms of concepts native to the TE, which are new for users and not well documented, they think in terms of the Docker containers and TLS connections, things that are very well understood.
Yeah, essentially, we want to make everything as easy, as accessible to even the non-technical user as possible. So the one point you mentioned is really, really good, is about the TLS connection, because usually when people are thinking about TE proof, they only think about, okay, there is a TE and my program is running in the TE, that's all. But actually, another very important property is that when you are talking with this program, you need to ensure the program you're talking to is exactly the program you want to talk. It's like you get a CA from some random people, then you want this CA to be the right CA if you want to jump into some meme coin, right? Very silly analogy. And here we borrow an idea from IPFS. So when you're accessing some content, IPFS hosts a static content like a website, web page, image, or video, and every content has a hash. So that is the IPFS CID, the hash of the file. So you just use the hash to access the file. So it ensures you can always check this file. If you hash it, you get this hash. So pretty straightforward. So we borrow this idea. That's why like you can have some kind of a hash of your program, and you access this URL, then you talk to this program.
Yep. Yeah, and so I guess it still has some caveats, right? So like, for example, when I look at the Docker container, right, like a good example of a Docker container, which is not a good Docker container, is a Docker container in which SSH access is not disabled, right? So if SSH access is enabled, that means that the operator can SSH to it and do nasty things to my data, right? So it still requires quite a bit of diligence in looking at the Docker container, making sure that it's secure and that it's in fact only interfacing with me via the API and not in any other way with anybody else. But it still simplifies it quite significantly.
Yeah,
Right.
that's right. I'm thinking now it's pretty early, but in the long run, probably people are going to develop a similar ecosystem, or like a habit of other blockchain ecosystem. So you have a program, so you need to open source it. Otherwise, nobody know what is running inside. You can easily have a backdoor. Nobody can easily detect it. And on the other hand, we also want people to audit the code. Like when using DeFi project, I will not use it if they don't have audit report. And at least having some people auditing it can give me some kind of secure feeling. It's way better than nobody else taking into the code. And then the problem is we also need to ensure the auditors can really audit the code, and we can link the code back to the proof. So this is actually turned out to be a little bit trickier thing because how people do that in a smart contract is usually you have the code and there are a bunch of configurations. You apply this configuration to the code, and it will compile to the smart contract. And if you can do that, I can also do the same. So everyone can repeat the same process to get the exact same output, the compiled smart contract. Because compiled smart contract is just a blob of binary. You cannot really see what is inside. So having a way to map the source code to the binary is very important. We call this a reproducible build, or sometimes people call that a deterministic build. And this is not enabled by default for most of the build system. So this is also remain a challenge. But I know there are already a bunch of good people working on that. Say Nix is a project that can allow people to build a lot of things deterministically. And there are also some other ways. For example, if you run the JavaScript or Python code, then you don't really compile the code to the binary. You just copy and paste all the code bases into the Docker image. Then you can just open the Docker image to check if those files exactly match the one in the GitHub repo. So those are also the things I think it's a challenge, but I do think people can find a really good solution in the very near future.
Yep. Yeah. So another interesting thing to mention here is that, so I was talking yesterday to a friend of mine who is working on like he doesn't work in Web3 at all. They work on like edge, deploying databases on the edge, right? And one of the problems they have is that now that all the databases are in the cloud, right? Effectively, enterprises need to trust those providers, database providers, etc., with their data. And enterprises they really don't like trusting other companies with data, right? And so I mentioned the TEs, and the person was, like they were in denial that this technology could exist, because if it existed, then all the problems would be solved, right? So I think it's we're like at the very early stages of that technology getting widespread not only in the Web3 space, but in the Web2 as well, right? I think but the Web3 will be a catalyst for that. I think for that technology to become, like for all the tooling to appear for all the. So I'm curious to hear what use cases you guys see as obviously private inference. That's something that everybody's very excited about. But what other use cases are going to be you're most excited about?
Yeah, most excited. This is a good question. To me, I do think a lot of use cases are really exciting. I don't have like a ranking for all of them. Just to name a few in the Web3, and probably Marvin can also add some add up something later. So first of all, from the purely Web2, very deep Web3 side, one thing that is pretty interesting is MPC. So MPC bridges, MPC wallets, and a lot of MPC use cases. And it turns out because of the limitation of the MPC algorithm, usually you can only have a few nodes or like tens of nodes. You cannot have 100 or even thousands of nodes. So this is a limited degree of decentralization. So with limited node, how can we ensure the network is still resilient enough? So a way to do that is you just put the MPC node into a TE. Then if you want to compromise the MPC node, you need a few MPC operators to collude together, and at the same time you also need to break the TE. So the two things are completely different. So you get another layer of security. So people call this defense in depth. And another, I think, a very interesting use case is from Web3, privacy inference is one thing, right? In the pipeline, or I mean, in the supply chain of machine learning, you need to have data, and then you need to train model, then inference, and the inference result is consumed by the AI agents. Especially recent days, AI agents is pretty popular in Web3. So in this whole pipeline, we need the both privacy and the integrity. And also, say if we want to monetize the model, if like we put a lot of resources to train open source model, and then people just take the model and use it for free without giving back any value to the community, this is a problem, right? But if we can put all the models, the data side, the data preparation side, and the training and the inference all in the TE, then we can protect this model weights, and the model is owned not by just one person but multiple persons, all the contributors. It can be like a token holder of a machine learning model DAO or something like that. Then this can make a lot of things that doesn't work in the past, even in Web2, that can work in Web3. And then once we have the model, we can have the AI agent to consume the model. And the AI agent also needs TE to ensure this is real AI. It's not human controlled AI. So like they cannot manipulate how AI interact or run to provide a service to the users. So in this process, I think is also very interesting, because clearly the other solutions cannot help a lot. Because AI is already really data intensive. We cannot spend, say, thousands times of more money just to train a model or run the inference. It's already very expensive. So TE is an enabler for those technologies.
Yeah, I want to emphasize. You mentioned it, but I just want to reemphasize that for the model inside of the TE, you can achieve an interesting property where the model would be in a state where everybody can get it from anybody else who already has it, right? So like if I have it inside of my TE, right, and it probably wouldn't be the model, right? The model probably would be on the disk, it just would be encrypted, right? What I have in the TE is the decryption key, right? Then we can have the API that allows anyone else running the same Docker container to get the decryption key from me, right? So effectively the model is fully decentralized. Nobody can prevent anyone else from getting it, right? But nobody can use it for free, right? The only way to use it inside of the TE is by opening a payment channel, right, and doing the inference. right? So that gives you the best of both worlds in the sense that everybody can get the model. You can even expose the API to fine tune it, right? So everybody can get it, everybody can tinker with it, but nobody can use it without paying the original developer, right? Which is
exactly, just like the first ever personal owned model. Just like the first time I know how Dropbox work, right? I can own some digital space to storage my photos and other drives. But in this time, like you can actually own yourself a model. You can customize it. You can import your database into it, fine tune it. But the ownership is yourself, and if you want to share to others, that's your job. But you could also keep it for yourself. I think this is the most exciting moment for us.
Yeah, and I think another very interesting application is that, today. So first of all, today nobody publishes the training loop, right? Training loops are the know-hows, right? But I think even if someone did publish a training loop, that is no guarantee that the model is actually the result of the training loop, right? So if a model is trained by, let's hypothesize there is a country that brainwashes their population. I don't know if any such country exists, but let's assume for a second it does, right? And they publish a model, you would expect that model to be to have the biases, right? And even if they publish code and the code has none of that logic, there's no guarantee that that code indeed was created, was something in fact that created the model. But with TE, you can actually design your training loop to be running inside of the TE for practically no overhead, right? Like with B100s, I think that is something that NVIDIA is striving for, to have almost zero overhead, right? But then you can have this attestation at the end that says, hey, as a matter of fact, these weights are the output of an orchestrated effort of many machines running this very code on this very data, right? And so now you can inspect the pipeline and say, well, there's no biases in fact in the model, right? And so it's safe to use. So I think this is a really exciting application piece as well.
Yeah. Oh, on top of that, I do have an interesting idea. Not sure if anyone else has explored before. So, in science area, researcher area, one problem of the research field is that people want to make sure all the research is reproducible. But sometimes, like for a lab, you still don't want to just give out everything to the others, because you still want to take some advantage. So what people do right now is they write the paper, but maybe in the paper they hide some of the tricks when they work on the paper, or like when doing the model training, they have some specific cherry picked input data or some tricks. But then it means that if they cannot open source everything, nobody else can reproduce this research result. So probably another thing people can do with this model is that they can reproduce, they can make all the things happening in a TE, and the TE can give a proof, also the proof of the satisfaction of some property in the training process or the data preparation process. So yeah, I think this can also be a really value add up to the research field, because it can remove a lot of like academic fraud, and can generally make this field much easier to make progress without worrying about people stealing others' data or ideas.
Yep. Yeah, I don't know if it helps against cherry picking. I can still cherry pick the best inputs and give you the proof that they run inside of the TE. But it definitely helps with the, like, I'm pretty sure that half of the papers published have completely made up or inflated results, right? So that is fully solved, right? Like, you just have, and it, a proof that like, we did have a model that gave that good of result on the benchmark, right?
Yeah, it can prove the existence, but not the, people can still cherry pick data, but at least say if I train a model and it said this model have a very high accuracy, and if the test set is open source, then this can ensure at least you have a model that can match this accuracy.
Yeah, it's not necessarily the one you talk about, but yeah, it's at least, you can definitely get like it's a spectrum, right? On one end, you can publish the whole code and the full proof that this code is in fact giving you this result, right? Or like you can say, hey, this is the code, but I also have a set of hyperparameters I'm not going to tell you. And with those hyperparameters, you get this good result, right?
Yeah.
Right. And you can have like, or like on the very far end, you can say, hey, I have something and it's a complete black box, right? I claim that this is what I say in the paper, right? But it's a black box. I'm not going to show any results, but I will still show you that they have something that gives this result on the benchmark, right? So at least you know that I didn't completely make them up. So it's So TE at least gives you tools to be able to be on that spectrum, right? Because today, without the TE, the only thing you can have is either publish all the code for people to be able to run it themselves and get the same results, right? Like this is the only way to have any reproducibility.
Yeah.
Okay, so we're running out of time, but I guess, is there anything else that you think is particularly exciting that people should know about TEs or Phala network or what's coming?
Yeah, to my perspective, I also want to introduce like several kind of direction we are working very hard into both from AI besides the private or user owned model. We are also very into like the browser based operator for AI agent. I think OpenAI presented this a couple of months ago, right? And basically nobody really using it every day. But I think the specific reason is probably the perform or the efficiency is not still like the best, right? But we can see how it unlock a lot of potential ideas and use cases, because based on VI, the agent can read any website and access, to work for you with your personal account, with your approval, of course, without pre-programming. So you don't need to like integrate APIs to have that. So this kind of browser-based agent exister definitely will unlock a lot of use cases. But of course, none of us want to dedicate our accounts to OpenAI because I don't want to, insert my MetaMask private key into the cloud browser of OpenAI. Definitely not. So we need some security environment to run it. I believe this is a potential, collaboration or interesting use case from near AI, and we are happy to provide the TE powering this. Another direction is collective intelligence. This means that you see how DeepSeek changed the efficiency of breakthrough of these benchmarks by using the MOE, a mix of experts in a really smart way, change some incentivization, reward incentivization mechanism for these multiple models, and change the way how they rank the incentivization layers. So we think collective intelligence can definitely bring a breakthrough for intelligence, even with a very, very low cost. I think this could be a next direction for multiple AI agent ideas. And I think by using TEE, we can build something cool around it for the for multiple agent-based collective intelligence. So this is super possible. But most exciting moment for us will be, will there a second DeepSeek level of breakthrough from Web3? I think is possible for all of us, include Near and other teams, because the team behind DeepSeek, after all, is a quantum trading company backed sub company, right? I be using very limited resources and make some breakthrough. I think this could happen in the crypto space too.
Yeah, certainly.
Awesome.
Okay, cool. Okay, thanks a lot, guys, for coming and for the great discussion. And excited for what's coming next.
Thank you, Alex. Glad to chat with you. Yeah, thank you.
Thank you for hosting. Thank you, all to be here.